Okay, welcome to week 5 of geometry distance learning. And I did check and made sure that the microphone is actually recording today instead of me just writing on my iPad screen. So in this week's lesson, we're going to talk about quadrilaterals. And then there is an assignment that you're going to need to do with quadrilaterals. I have 12 slides according to the iPad, so we're going to go ahead and get started. First of all, what is a quadrilateral? Press pause, answer the question to yourself, to your sister, to your brother, to your mom, to your dad, to your dog, or cat, or fish, or ferret, or whatever pet, or anybody who will listen to you. It could just be you talking out loud in your recording studio. I have a recording studio. I do. Really. No, not really. Basically, I have very few rooms in my house that have a locking door, and I find one of those few rooms with a locking door, and I close the door and I lock it, and I tell people I'm doing my recordings so that they need to leave me alone. All right, so what is a quadrilateral? A quadrilateral is a polygon with 4 sides. You are correct. Now, these sides could be. You could have parallel sides. You could have sides that are perpendicular to each other. They could be the same size or congruent. They could be different sizes. So that's not. Whoa! iPad did something new. I downloaded the update. That is new. Whoa, let's first of all, let's get rid of that because that's not the shape that I want. They could look like that. Remember we were talking about triangles? Now it will snap triangles. It snaps circles. Circle is not a polygon. That's not actually what we're talking about. And what's the difference between this one here and this one here? Yes, 4 sides versus 3 sides. Good. So we've already talked about triangles. We're going to talk about quadrilaterals today. I'm really excited my iPad does something new. You guys always laugh because you know I don't figure these things out until I actually do something, and then I'm like, whoa, it did something cool. So needless to say, apparently now Notability will snap things into polygons. So we're going to be looking at the quadrilaterals. Some of our sides might be parallel. Some of our sides might be perpendicular. Some of them might not be. So maybe they're, well, that's not really what I wanted, but that's okay. Some might be the same size. Some may have different sizes, and we're going to talk about all of those different kinds of things today. So let's talk about this is my favorite one. Let's talk about the square. So a square is a polygon. More specifically, it has very unique pieces. The first thing that you need to know is that opposite sides of a square are, you got it, they're parallel. So a square is also a parallelogram. I'm going to draw you a picture later and you get some ideas. But a square is also a parallelogram. Squares are also unique because all 4 sets of sides are perpendicular. Since all 4 sets of sides are perpendicular, it fits the category called a rectangle. Again, other names that we're going to talk about. And the other cool thing about parallel squares is that all 4 sides are equal. So again, remember the little lines indicate that pieces are congruent. The little arrows indicate that opposite sides are, or those lines are parallel. So, squares, what can we find about squares? Well, you might want to find the length of the diagonal. You could use Pythagorean theorem to do that. You might want to find the area. More specifically, let's go ahead and find the area of this. How do we know it's a square, first of all? Good. 3 out of the 4 sides are the same. And these two, this side angle and this side angle, since they're both 90, this line and this line are parallel. How do I know that they're parallel? Because they are cut by a transversal. Yes, we're going backwards. And since the two green angles, or these angles right here, are both 90, 90 plus 90 is 180. Therefore, because the same side interior angles are supplementary, the two lines formed, cut by the transversal, the purple lines with the little arrows, are parallel to each other. So that's just a review from our previous math that we were looking at. But in this problem, what I actually want you to do is I want you to find the area. So, anybody remember? Yep, you're right. We're going to take the base times the height, which in this case is the side, times the side, which we could say is side to the power of 2. I don't ask you guys usually to memorize formulas. I ask you to understand the process of where we're actually going to do this. So the area on this one, I would just write as 4.3 times 4.3. And that's actually how I do it in my calculator, which I'm getting at my phone. And 4.3 times 4.3... I can't type today. 4.3 times 4.3 is 18.49. What are my units? Kilometers to the power of 2. You're right. All right, so there's squares. Squares are also parallelograms, and they are rectangles, but they are specific types of parallelograms and rectangles. So this would be the square would be the most specific name that we could name this shape. All right, so what is a rectangle? A rectangle is similar to a square in the fact that opposite sides are parallel. We also have all 4 sides intersecting at right angles. The other thing is that, let's pick a new color, green. Opposite sides are congruent to each other, but not all 4 sides are necessarily congruent to each other. So the opposite pairs can be congruent, but they're not necessarily all 4 sides are the same. All 4 sides are the same means that we have a square. Exactly. So rectangle is a broader type of our quadrilateral. It's broader than square. Square is really, really, really specific because all 4 sides have to be the same. And all of the same things that are true about rectangles also have to be true in squares as well. So I really didn't have any example problems for squares. All right, so what's a parallelogram? To me, a parallelogram is a rectangle that got like squashed or pushed sideways. So parallelograms. Opposite sides are parallel to each other. Okay, opposite sides are parallel. Opposite sides are also congruent, meaning they're the same length. But what they're not is they do not necessarily intersect at 90-degree angles. However, what we do know about the angles is that the opposite angles are going to be the same. And the opposite angles are going to be the same. So there's our parallelogram. If we push that parallelogram back up to vertical, then it's a rectangle. So every rectangle is a parallelogram. Therefore, every square is a rectangle. So therefore, every square is also a parallelogram. All right, so let's look at some problems. Let's talk about 2. First of all, area. Area of a rectangle, area of a square is easy. It's just the base times height. But a parallelogram is a rectangle that's been just kind of pushed sideways. Now, what would happen if I took like this piece of the rectangle or the parallelogram. Where could I put that? If you said I could put that piece up here, and those two yellow pieces are exactly the same size, I could take it off of the bottom, put it onto the top, and then we notice that we actually have what shape? You're right, we have a rectangle. We have a rectangle with a length of 9.1 and a height of 6.5. So therefore, to find the area of a parallelogram, we're just going to multiply the length of the base, okay, times the height. So the area on this one is going to be 9.1 times 6.5. Okay, so 9.1 times 6.5. Again, get out your calculator. And we have an area of 59.15 units are feet to the power of 2. Now, number 5, I'm telling you ahead of time that it's a parallelogram, so what do we know about the opposite sides? Opposite sides are parallel, and they've been cut by a transversal. So what do we know about these two angles inside? So if we go back, we know parallel lines cut by a transversal. Remember we did this in the hallway where I had you guys do like Dance Revolution, and I made you guys like get up and move around, and you guys thought I was a little cray-cray. But y'all did it, so I appreciate that. But these two angles inside, so angle 1 and angle 2, are both on the interior of the parallel lines, and they're on the same side of the transversal. So yes, they are same side interior, which means 62 plus that should actually equal what? You're right, they're supplementary, so they're going to add up to 180. So 18x plus 72 equals 180. We're going to subtract 72 from both sides. So 18x is equal to, I think, 108, right? Check my mental math. Yeah, minus 72, 108. So we're going to divide by 18. Divide by 18. X is equal to, and don't ask me what 108 divided by 18 is. It's 6. So apparently I can't do real math. All right, so x is 6, so we actually solve that in the parallelogram. All right, next shape, trapezoids. I like trapezoids. I think they're kind of cool, because the cool thing about a trapezoid is that only one pair of sides is parallel. The other pairs of sides are not parallel. Now, there's two specific types of trapezoids. The trapezoid on the right, let's call it trapezoid, we'll call it trapezoid number 2 versus trapezoid number 1. Trapezoid number 2 has two sides that are not equal to each other, whereas trapezoid number 1 has two sides that are congruent. Now, the base at the top and the base at the bottom are not the same size. Same with trapezoid number 2. Base at the bottom and the base at the top are not the same size. But the cool thing about this one is that this piece does not equal this piece. They're not the same size. Okay? So, trapezoid number 1, what do we call a triangle where two of the sides are equal to each other? You're right. It is an isosceles, but it's not an isosceles triangle. It's an isosceles trapezoid. Versus number 2, which we would just call a trapezoid. Now, in a trapezoid, we don't just have the lengths of the sides. We also do have a vertical piece that we identify as the height of the trapezoid. Because we do know that they're parallel lines, the top and the bottom are parallel lines, the height between base 1 and base 2 is the same throughout the entire thing. Okay? So, we're going to need that. Because how do I find the area? You're right. So the area of a rectangle is just base times height. We all got that. But the bases, base 1 and base 2, are not the same. So the area of a trapezoid is still base times height. But because base 1 and base 2 are not the same, I actually need to find the average of the bases. The average of the bases times the height of the trapezoid will give me the area of the trapezoid. Well, how do I find the average of the bases? Right, I'm going to take base 1 and base 2, and I'm going to divide that by 2, because that's how we do average. We add two things together and we divide by the number of things that we added together. So in this case, I added 2 things, so I divide by 2. If I added 3 things, I would divide by 3. That's why we talked about the mean in the last couple of units, and this is why this is, again, this idea of average. Average is mean. So we're going to multiply add base 1 and base 2, divide by 2, and then multiply that by the height to find the area of the trapezoid. You're correct. All right, so how are we going to do that in question number 1 for trapezoids to find the area? You're right. So we're going to average the bases. So we're going to take 2.7, add that to, not 3.2. What's the other base? You're right, 6.9. We're going to divide by 2, and then we're going to multiply the whole thing by the height, which is 3.2. Again, you guys know I don't like formulas. It's still base times height because it's a quadrilateral. The big difference is that the base, because they're not the same length, we actually need to do a little bit of calculation. We need to find the average of them. So we find the average of them, and then we multiply it by the height. All right, so calculator's handy. Hopefully you guys got your calculator out, but hopefully you have them handy. So 2.7 plus 6.9 is, say, 9.6 divided by 2 will be 4.8 times 3.2. Or 15.36 units are inches to the power of 2. Now, on these problems, I may also ask you for angle measurements. So we're going to be using, again, that previous knowledge that we have. We have parallel lines cut by a transversal. So that means the 142, this angle, and angle M should add up to what? You're right, they should add up to 180. So measure of angle M is equal to 180 minus 142. 180 minus 142 is 38 degrees. You're right, it's not 33. I apologize. 38 degrees. All right, one last shape. We're going to talk about the kite. The kite is unique because we don't necessarily have parallel sides. The kite's unique because the sides that are adjacent to each other, one pair of adjacent sides, are congruent. So that pair of sides is congruent, and this pair of sides is congruent. So in kite, let's call this let's go red. A, B, C, and D. AB is congruent to BC. And AD is congruent to CD. Okay? So they are congruent to each other. All right. The cool thing is this shape, if I wanted to, wow, that's a really bad line. I apologize. And it doesn't want to be right in the middle. It can be split. That's what, like, the traditional shape of a kite that we fly kind of looks like. Yep. And what we end up getting is these lengths, which we're going to call diagonal 1 and diagonal 2, the distances across from each other. Okay? Now, the cool thing is this actually gives me how many triangles? Gives me 4 right triangles because the diagonals of a kite all intersect at 90 degrees. Okay? So, let's take a look. I'm actually going to start with this problem 2 first, and then we'll go to problem 1. But if I look at problem 2 and I ask you to find the length RH, you're going to tell me, hey, PK, I know that. That is nothing more than the, yep, you're right, hypotenuse of a right triangle. Specifically, 12 squared plus 20 squared is equal to RH squared. 12 squared is 144. 20 squared is 400 equals RH squared. So 544 equals RH squared. RH is the square root of 544, which is approximately, let me get my calculator out. Turn it sideways. Clear, 544 square root is about 23.3. Okay? Now, cool thing about this next one is I want to find the area. Now, what do we notice about triangles? We've got this triangle here, right? And this triangle is the same as this triangle. You're right. So if I flip the bottom triangle over, I have a rectangle. So if I take these two triangles together, triangle A and triangle B, A plus B is a rectangle. Right. So the area of A and B is just 8 times 15, or 80 plus 40 is 120. Okay? The cool thing is we can do the same thing on the other one. We could say this triangle is the same as this triangle. Put them together and we have a rectangle. Let's call it C and D. C and D. If I add C plus D, I also have a rectangle, right? So that's going to be 6 times 8. And 6 times 8 is 48. Therefore, the area total is just going to be 48 plus 120, or 168. Now, there is a formula for area of a kite. The formula for area of a kite is going to be diagonal 1 times diagonal 2 divided by 2. Okay, so in this case, it'll be 21 times 16 divided by 2. And if I verify using my calculator, 21 times 16 is 336 divided by 2 is 168 units or centimeters squared. Now, if we were in class, I would probably actually expound on this and explain where this comes from. This is why the first thing I showed you was actually just using the triangles and not a formula, because I don't, you know me, I don't like formulas. I'd rather just look at the problem as a whole and think about how can I break it down and solve it. All right, this week's assignment is a little different. It's not just some SAT problems. It's not a lab, but it's kind of like the lab idea. Your assignment is to choose a quadrilateral, so like one of the things that we talked about, and you need to create like a dating profile or like a social media page for that quadrilateral. So, you know, you might create like a profile for Instagram or a Facebook profile or Twitter, and you tweet out these different things. You need to include 10 facts or problems that are about or involve the quadrilaterals in your profile. So you may put together your own problems. You might have information about other quadrilaterals aside from the one that you chose to profile included in your profile. So like in my Facebook, I have my cousins listed, you know, or my children, or I might talk about other runners. So things that I have in common with other people. And I might have some problems that involve other runners or problems that involve my kids or something like that. Now, how can you create these? You can use paper and pencil, and you could draw really cool pictures. You might want to use a computer, and you use a Google Doc or a Google Slides. You can use your phone. Maybe you're taking pictures of quadrilaterals in the real world and you're identifying different pieces about them. I want you to be as creative as you can in creating this information about quadrilaterals. And again, you can choose the quadrilaterals that you want. What I didn't show you guys and I want to introduce to you guys is this idea that quadrilaterals kind of have like a hierarchy, not really a hierarchy, but quadrilaterals start like big, right? Quadrilateral just means 4 sides, okay? And in our quadrilaterals, we could have some specific things. We could have this idea that there are sides that are parallel, meaning that we have parallelograms. And within our parallelograms, we have rectangles. And then within our rectangles, we have squares. The further down the branches of this like tree diagram, the more specific that you have. You might also have a kite. Remember, a kite doesn't have parallel sides. All right, so this idea of quadrilateral being this overarching thing, and then we have specifics based on that. So be creative. Maybe you're drawing me pictures. Maybe you're somebody who likes to draw pictures and take notes and identify things. I want you to try to be as creative as possible with creating this idea of a dating profile or a social media page. I want you to give me information that you know about quadrilaterals or the quadrilateral that you choose. Again, you might have 10 facts or you might have problems. So maybe you have some area problems or you have some perimeter problems or you have information about their angles. But I want you to be as creative as you can. I am going to be looking for this idea of 10. So I'm looking for you to show me at least 10 things that you're going to find. Again, I have office hours on Thursday from 1 to 3. I did not delete my office hours for Tuesday morning from 10 to 11 or Wednesday from 10 to 11 and 2 to 3 or on Friday from 10 to 11 and 2 to 3. But Wednesday from 1 to 3 is that, or Thursday from 1 to 3 is that big one that doesn't overlap with other subject areas. So I'd love to see you online. Message me questions if you have any issues with Google or forms. Please let me know. Hope you guys are all well, and I will talk with